Hello Year 10. I'm sorry I can't be with you today, but unfortunately I'm self-isolating. But you will have a cover teacher who will be there to help you with today's lesson. Today we're going to look at energy resources. Can you please make sure that you have written this as a title together with today's date? So energy resources, nice and neatly underlined together with the date. On screen, a photograph, and in 1991, during the first Gulf War, the Iraqi army retreated when US forces came to the aid of Kuwait, which is a small country, but it's an oil-rich country in the Middle East. And when the Iraqi army left, they set fire to around 700 oil wells purposefully to destroy useful resources. And you can see here one of those oil wells dramatically on fire. Here's another photograph of that from the air, and here's some aircraft flying over these oil fields which are set ablaze. Here's an even better photograph of that. You can see down here just how much smoke and soot is being produced as a result of these oil fires burning. Now, the problem with fossil fuels are non-renewable. This is an important definition. Can we write this down? Non-renewable energy comes from sources that will run out or will not be replenished in our lifetimes, or indeed in many, many lifetimes. So crude oil, coal, natural gas are all types of fossil fuels that will eventually run out. So most non-renewable energy sources are fossil fuels, such as coal, oil, and natural gas.
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms, like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
Okay, hooked on fossil fuels. At the moment, as a planet, as a species, we are very, very reliant on fossil fuels. I would say, overly reliant on fossil fuels. The International Energy Agency, which defines how much energy is being produced from each of our resources, both renewable and non-renewable, says that primary energy supplies in 2013, bear in mind this is 7 years ago, 36% of all of our energy was generated from oil, 26% from gas, 19% from coal. These are the non-renewable energy resources. 10% from nuclear. Nuclear is also non-renewable, but we've got a lot of nuclear fuel. It will take an awful long time to run out. 5% from biofuels and bioenergy, such as biomass and so on. 2% from hydroelectric power, and 2% from wind, solar, geothermal and ocean. And what this shows quite dramatically is that fossil fuels drastically outstrip renewables, which is a big problem, because if not within my lifetime, then certainly within your lifetime, all fossil fuels will run out, which means that we need to become increasingly more reliant on renewable energy such as bioenergy, hydroelectric power, wind, solar, geothermal, as we will see. What do I mean by renewable energy? Renewable energy is sometimes defined as being green energy, which is why it's in this green box here. An important definition then, really if you know what non-renewable energy is, you know what renewable energy is, but renewable energy can be made at the same rate as they're being used. In other words, renewable energy sources will never run out. Please can you pause the video and make sure that you've got that important definition down in terms of renewable energy. Okay, in a moment the cover teacher is going to hand out to you a map and a table. The map looks like this. As a scientist, you're going to suggest the most appropriate location for each renewable energy option on this island. You need to think about the terrain. Is it going to be flat, dry, coastal, and so on? Because this will affect where you place each type of renewable energy option. The type of renewable energy is on the table, which I will go through next. So on the table there is solar, wind, tidal, biofuels, geothermal and hydroelectric. What you can do is to use your phones, of course, provided that we're using them for an educational purpose, to explain both the advantages and the disadvantages of each of these types of energy. You're going to also describe where the energy comes from and why it is a renewable energy source. So really, there's two things for you to do for each of these renewable energy sources. The first is to place it onto your map, but thinking about the advantages and the disadvantages as well as where the energy comes from. So I would be tempted first to fill in this table actually, and then place your source on the map overleaf. So this should take you quite some time. I would think 15 to 20 minutes. I'll leave it to the cover teacher to determine how productive you are being before we go through some case studies and finally go through all of the answers. So please pause the video to complete these tasks. Okay, so hopefully you've had the chance to go through that sheet and have filled it in. It's absolutely fine to collaborate if you need to do so, to get help from others. What we're going to move on to now is a 6-mark question. So I'm going to let you choose a case study. The cover teacher will come and hand out a case study sheet. On one side there are 3 case studies, and on the other side there is a task that I'd like you to do. So you need to choose a case study and plan and compose a 6-mark answer. use that case study help sheet if you really need to really nail home the points that will get you the marks. So pause the video, have a go at that task now. This I think would take you again between about 10 and 15 minutes. Right, okay, hopefully you've had the chance to fill in all of that information on your sheets. We're now going to go through each form of power generation in turn. You need to fill in the advantages. The advantages are in this green box here. The disadvantages are in this box here, and this is how the energy is generated. So essentially this is the first box on your table, this is the second box on your table, this is the third box on your table, and we're going to take these in turn. If at any point you need the cover teacher to pause the video, please raise your hand and let them know whilst you're filling in this information, because we'll go through each one in turn. So the advantage of solar power is that it's small and it's portable. It can be used in very remote locations, it's got a relatively low running cost, and it doesn't produce any form of emission. It has no pollution as a result. The main disadvantages are that it is expensive to buy, but also it's not reliable. It needs intense sunshine to be effective. Hence why in this country we do not generate a lot of our electricity from solar power. It just isn't reliable enough because it's not intensely sunny in this country. How solar power works? Well, there's actually two forms of solar panel. There's solar cells, which can turn the sun's energy into electricity, and there's solar panels, which heat water that flow through them. What you'll see in this country on people's roofs aren't solar cells, they're actually solar panels, which heat water. So all throughout this system here will be a network of pipes having a high surface area that the solar panels will heat up to heat the home. These, however, are solar cells. These are used in very intense sunshine, so countries or areas that are very sunny, to generate electricity. The two things are not the same. Please do not confuse them. If you need a bit of time to write this up, please just raise your hand so the cover teacher can pause the video now. Otherwise, we'll move on to wind power. Okay, wind power works through a wind turbine. The wind turbine has some blades here and a rotor which is connected to a generator. And as the rotor spins, it generates electricity. So the massive advantage here is you don't produce any form of pollution and you've got relatively low running costs. The main disadvantages are that they are unreliable. Obviously, if it's not windy, you're not going to produce any electricity. It's the same really as solar power in that regard. It is also immensely expensive to build as a result of them being also visually polluting. They're a bit of an eyesore, many people think, and they also generate quite a lot of noise pollution. For that reason, they're often built offshore. So you will often see offshore wind farms whereby you have a turbine that is out at sea. That increases the cost dramatically to build it out at sea. And obviously it increases the maintenance costs as well, because you've got to send a little boat out to maintain it. But it does have the advantage, if you build it out at sea, at reducing the visual pollution and the noise pollution as well for local residents. Often people will complain that wind farms don't look very nice and are a source of noise pollution, so they don't want them in their backyard. A wind turbine, how it works then, a wind turbine has a generator at the top of it. They are often placed at the sea, as we've seen, or in the countryside in remote locations far away from people. And the wind causes the blade to spin, which in turn turns the generator, which produces electricity. As before, if you need to pause the video, just raise your hand for the cover teacher. If not, we'll move on to tidal power. So tidal power then. Tidal power has the massive advantage of being reliable because there are always 2 tides per day anywhere in the world. They're predictable because the tides can be accurately calculated. But the disadvantages is that although there are tides all over the world, unfortunately there are very few locations that will have a strong enough tide or indeed any major tide to generate electricity. The other disadvantage is that large areas are flooded, which destroys habitats and wildlife. They look like this, these tidal power stations. You have a trap of water from high tide behind a barrage. This is the barrage, and the generator is built into the barrage. So at high tide, you can release into the sea through these turbines, which turns those turbines generating electricity. As before, please raise your hand if you need to add some extra detail to your notes. Otherwise, we'll move on to geothermal power. Here's geothermal power, guys. The advantage is there's no pollution and there are very, very low running costs. The downside is that the cost of drilling several thousand kilometres down into hot rocks is jolly expensive. So it's only viable, that means it only works in certain places on Earth, for example in Iceland, and we'll look at Iceland as a case study next lesson. Here's how it works. So you have either a geothermal power plant or a geothermal heat pump. A power plant generates electricity for a community. A geothermal heat pump heats an individual house or a few houses. What you've got on deep underground is you've got hot rocks because you've got radioactive elements that decay and heat up the surrounding rock. This only happens in volcanic areas, hence why places like Iceland can only really be used. So you drill down a long hole into the hot rocks and you pump hot water down you pump water down into those hot rocks. You can then pump the water back out again, which is hot, and that hot water generates steam, which turns a turbine, which in turn turns a generator, generating electricity. In terms of a geothermal heat pump, you're just pumping the water around and using the hot water round your home in radiators to heat your home. Hopefully that all makes sense. Again, please make sure that you're adding to your notes. If you need to pause, stick your hand up. Otherwise, when you're ready to move on, we'll look at biofuels. So biofuels, there's all sorts of different biofuels. There's 2 main advantages. The main advantage is that renewable. So provided that you keep planting plants, for instance, and provided you've still got animals, defecating and leaving feces and leftovers, those will constantly be produced. So it's renewable. These sources will never run out. Biofuels should be carbon neutral, and I do stress should be because often they are collected using fossil fuels, so they're never 100% carbon neutral. But what carbon neutral means is that the plant or animal will remove carbon dioxide from the atmosphere when it's alive, which is then returned to the atmosphere when it is either dead or burned or buried. So you've got the amount of carbon dioxide taken up by the animal or plant and then released. And provided you keep planting plants, provided that you are keeping those animals, that livestock going, then it should be carbon neutral. The disadvantages are that growing biofuels takes up a lot amount of space. And as well as that space could be used for a variety of different things, but often that space is used for growing food. There are big questions about growing plants to turn into fuels where you could be using that same area to grow plants that could be used for food. So that increases food prices as a result, because there's only so much land on planet Earth that can be used to grow plants in terms of arable land. So as a result, it's supply and demand, the food prices will go up. Another big disadvantage is that burning biofuels produces lots of smoke, which results in air pollution. Also, if you use biofuels incorrectly, it can lead to deforestation, because if you're cutting down more than you plant, then that's going to be a problem and will lead to lots of forests being decimated, as is the case in the Amazon and other parts of the world. How does it work? Well, a biofuel is any fuel taken from living or recently living organisms, right? So feces, food leftovers, wood, bacteria, animal fats from corn. You could even use potatoes, all sorts of different things. Used paper, palm oil, peanut oil, algae can be used to create biofuels. It's a hugely versatile situation. There's lots of different things that you can use. The situation is that you can quite easily modify car engines that run on biofuels. For instance, biodiesel, which is made from corn and other plants, can be, and even things like vegetable oils, can run quite happily on spent vegetable oils if you convert them into proper biofuels, provided that your car has had some modifications as well. Again, hopefully all that makes sense. Please can you add to your notes? If not, we'll move on to hydroelectric power, which is the last type of renewable source of energy. Okay guys, this is the last slide on hydroelectric power. The advantages is it produces no pollution, there are no fuel costs, and it should, provided that you maintain it, last a great deal of time, a long time. The disadvantage, just as with tidal power, is that you've got large area of land which is flooded, which destroys animals' habitats. The other huge disadvantage here is that the cost to make a huge dam like this is astronomical. They are really, really very expensive to produce, but once you've produced them, provided you maintain them carefully, then you should get a lot of energy over a prolonged period of time. How this works is that water is collected and stored behind a dam. So here is a dam in a river system, and the water flows down through the dam from a higher gravitational potential energy to a lower gravitational potential energy. That gravitational potential energy is converted into kinetic energy when the water flows down from where it's at high gravitational potential to where it's at low gravitational potential. And a bit like the tidal power, that gravitational potential energy into kinetic energy, the kinetic energy turns a turbine, which turns a generator, thus generating electricity. So water flows down through intake channels and the energy is converted from gravitational potential into kinetic and therefore into electrical energy. I hope, guys, this has been really useful. If you have finished ahead of time, you could be quizzing each other on this. You could be coming up with some mnemonics to remember all of this, because it's really important. It crops up all of the time on exam questions, as we've seen. Hopefully everything makes sense, and I'll see you next time for our case study where we're going to look at Iceland. Thanks for your attention, and thank you to the cover teacher for looking after you guys. See you soon. Okay, at this point, I'd like the cover teacher to just in a moment flip to another video which is on fossil fuels and what are fossil fuels. What I'd like you to do during the course of that video is to write down 3 key facts, any key facts you think from the video as it plays. So please can you pause the video, write down the numbers 1, 2 and 3, leaving a bit of space in between each one so that you can write down 3 key facts from the video. Thank you.